Hi, welcome to Land of Math. In this video, we're going to work on how you can add scientific notation. We'll do a short review of some key concepts, and then we'll jump right into a few examples of how you can solve these problems. All that's coming up next on Land of Math. All right, so adding scientific notation. So first, like a little brief review of some key concepts here of scientific notation. Both these are examples of scientific notation right here. If you notice in red, these numbers right here are called the coefficient. They're always going to be 1 or greater, but they have to be less than 10. In other words, there's going to be one digit to the left of the decimal. Next, we're going to have times 10, and then we'll have an exponent. If the exponent is a positive, it means the number is greater than 1. If the exponent is a negative, it means it's going to be less than 1, or like a decimal. Now, when we move decimals, if I move a decimal to the right, the exponent actually gets less. So in this example right here, when I had 0.02 times 10 to the fourth, when I moved it 2 times to the right, the exponent went from 4 to 2. Here in this example, I moved it 1 time to the right, and the exponent goes from 5 to 4. On the flip side, if I move a decimal to the left, so when it was 42.1, if I move it 1 time to the left, like I'm trying to write it in scientific notation, the exponent actually gets larger. So here's another example. I move it 1 to the left, and the exponent goes from -4 to -3. Now just a little reminder, -3 is actually greater than -4. So here's our first example. So in our first example, we're getting ready to add these two scientific notations. One of the things we could always do is we could always write the numbers in standard form. So for example, the 7.1 times 10 to the third, I could just write as 7,100. And the 2.5 times 10 to the third, I could just write as 2,500. And I could just add those two numbers up. And when I do that, I get 9,600. And at that point, I just convert it into scientific notation. I would move my decimal 3 times to the left. I would get 9.6, and it would be times 10 to the third. So that's easy enough. But there's another way we could do this. What we're trying to do is if we have exponents that are the same, in this case we do, the third, we could just add up the two coefficients, 7.1 plus 2.5, and we get 9.6. And then we just keep the keep the exponent. So we just keep the 3. And so you see those two are the same. So in our next example here, you're going to notice that we have different exponents. We still could write them in standard form. So 2.1 times 10 to the third, we could write as 2,100. And 1.1 times 10 to the second, we could just write it as 110. So what we want to do is just add those two up. So 2,100 plus 110 would equal 2,210. And then we just have to move our decimal 3 times to the left. And that would give us 2.21 times 10. And because we moved it 3 to the left, that would give us an exponent of positive 3. So that would be written in scientific notation. But one of the things we can do is we can always take and try to convert one of the scientific notations into a situation where we have the same exponent as the other one. So, and we can do that actually either way. So if you look at the 2.1 times 10 to the third, if we make it the second, that means we make the 2.1 into 21. And so what we have now are these two right here. They have the same exponent of 2, and we just add up our coefficients. So we have 22.1 times 10 to the second. Now we need to write it into scientific notation, which means we have to move the decimal 1 time to the left to give us 2.21, and that would turn our exponent back into 3. So 2.21 times 10 to the third. You can also do it the other way. You could also take the exponent that's the second and turn it in to the third. So if we just keep 2.1 times 10 to the third, and we're going to change the second scientific notation, and it's going to turn into 0.11 times 10 to the third. Now we can just add these up. So 2.1 plus 0.11 is going to be 2.21, and that would be times 10 to the third. And that one's already written in scientific notation. You'll see that all three of these are all the same answer. So any of these three methods would work. So here's example number 3. Example number 3, We have our two scientific notations right here, 2.7 times 10 to the fourth plus 9.1 times 10 to the second. Now we could write them in standard form like we have up here and make it 27,000 plus 910 and then write it in scientific notation like we did. But we could also convert and make it so the exponents are the same. So in this case, we're going to try to make them into the second. So 2.7 times 10 to the fourth turned into 270 times 10 to the second. Now we can add these up because we have the same exponent. So 270 plus 9.1 is 279.1 times 10 to the second. And you'll notice right here, to get it in scientific notation, we have to move it over 2 times to the left. So now it's 2.791, and that's going to turn into, because we moved it twice, that's going to turn into 10 to the fourth. And that answer right there is the exact same as when we use standard form. Example number 4. So when we're looking at this one, now we have negative exponents here. We still can write in standard form and add them up. So 2.1 times 10 to the negative first is 0.21. And our other example would be 0.016. If we add them up, we get 0.226. And in scientific notation, it would be 2.26 times 10. And because we had to move it over 1 time to the right, it turns into a negative first. So we could do that if you wanted to. But the other thing is just to make the exponent the same. So let's say we're going to change the one that has the negative 1 as an exponent into a negative 2. We move 2.1, we move the decimal 1 time to the right to make it 21 times 10 to the negative second. And it's going to be the same as the other one, because that one will also have the same negative 2 exponent. When you add the coefficients, you get 22.6, and it's going to be times 10, and it'll be that negative, negative 2, because they're the same. To make it in the scientific notation, make sure it's between 1 and 10. So we move the decimal 1 time to the left to make it 2.26 times 10, and now it's negative 1 because we moved it 1 time to the left. And you can see those are the same. Example number 5. So in this one we have again 2 negatives. Again, you can write it in standard form. So 1.1 times 10 to the negative first would be 0.11. 3.3 times 10 to the negative fifth is going to be point, and then there's going to be 4 zeros and then the 2 3s. When you add that up, you're going to get 0.110033. You'd have to move your decimal 1 time to the right, and your answer would be 1.10033, and that would be times 10, and that would be because we moved it 1 time to the negative first. Now, the other thing we could do is just convert both of these so they have the same exponent. So let's say we change the one that had the negative 1 exponent into a negative 5. That means you would move your decimal 4 times to the right. And when you do that, you have 11,000 times 10 to the negative fifth. So now you have negative 5 for both of these. When you add up the 2 coefficients, you end up with 11,003.3 times 10 to the negative fifth. But now we have to write it back into scientific notation. So we're going to have to move this 4 times to the left. And so when we do that, we end up with 1.10033. And again, it's times 10 to the negative first, just like with the other one. If this video is helpful, we'd love it if you'd give it a thumbs up. It'd also be great if you'd subscribe to the channel. That'd be awesome. And until next time, we'll see you on the land of math.